This is the cartoon depiction of GTPase H Ras. We refer to this as the cartoon depiction as it's not really what the protein looks like on the microscopic level. It's quite a small protein, and all these twists, turns, and arrows are made up of amino acids, and we refer to these structures as secondary structures. Before I talk to you about secondary structures, however, I want to talk about these two little blue sections at the bottom of the protein. This light blue section here is actually called switch 1, and this dark blue section is known as switch 2. They're called switch 1 and switch 2 because they require the binding of specific molecules such as GTP and magnesium for the protein to be switched on. GTP binds in between these two, in between these two switches, and the switches are strategically positioned on the outside of the protein to allow for easy binding of molecules such as magnesium and GTP, which makes sense because you want it to be accessible for the molecules to bind. Magnesium is actually bound down here, and it's this big green sphere. It acts as a ligand for the hydrolysis of GTP, which is the function of this GTP Ras protein, and it helps facilitate the hydrolysis of GTP. There are a few grayed out amino acids over here that we can't see, and that's not to say that they're not there. That comes down to experimental error, which has resulted in insufficient crystallography. We know exactly which amino acids are there, but we can't know the exact projection that they have. So it comes off as if magnesium is free floating, but actually it's bound to the 35th amino acid, which is thymine, which is really important to note because it's bound here to switch 1. Okay, so I'm going to switch it over to the secondary structure colors so that we can see where the secondary structures are. Now, these secondary structures, the red ones are the alpha helices, the yellow ones are the beta pleated sheets, and the green ones are random coils which connect the two together. Now, it's important to note all these structures are made up of amino acids. That's just what they are. It's just that different sections of amino acids and different sequences of amino acids will respond differently to each other and form different secondary structures. On the protein data bank, we see that there are 6 alpha helices, whereas here we can only count 5. The reason for this is that this really long alpha helix over here is actually counted as 2 because it's kind of cut out. We can't really see that, but that's the way it actually works. We can count 6 beta pleated sheets, which is the actual amount of beta pleated sheets, which is nice. And yeah, the tertiary structure is a combination of all these secondary structures, and it's pretty much in essence the entire protein that we're looking at. GTP H Ras works as a single protein, a single standalone chain, which means that it does not require other proteins to help it fulfill its purpose, its function of cleaving the hydrolysis of GTP to GTP and the free floating phosphate.